Okay, last lesson in Unit 1. Good deal. You're almost through. I promise this one will be shorter than the last two. We are just going to talk about complex fractions. It's not going to take too long. So let's get right to it. We're going to simplify complex fractions. People see the word complex and the word fractions together and they think, oh my gosh, this is going to be terrible. But it's really not. Let's look at it. If we have 2x over 27y squared, and then we're going to put that over 6x squared divided by 9. This is what we call a complex fraction. The definition of a complex fraction is any fraction within a fraction. In other words, if you've got a fraction that is in the numerator of a bigger fraction, or you've got a fraction in the denominator of a bigger fraction, or both, like this is, this one has a fraction up top and bottom, then that makes it a complex fraction. Well, let's remember something here. This fraction bar right here is just another way to say division. Remember, fractions are just division problems we haven't done yet. So I could rewrite this as 2x over 27y squared divided by 6x squared over 9. That's really all it's saying. It's just a different way to package that division problem. We wrote it as a complex fraction, but we can break it down and write it now as division. Well, you should know, how do we divide fractions? That good old-fashioned keep, change, flip maneuver. Or, as Missy Elliott would say, you got to put your thing down, flip it, and reverse it. Right? I know you know what I'm talking about. If you don't, then that reference may be a little dated. Sorry about that. It was cool back when I was cool, I guess, if I was ever cool. I don't know if I was ever cool. Oh well. It's just now coming to me. We've got 2x over 27y squared, and then we're going to change the division sign to multiplication, and we're going to flip the second fraction. That's how you work a division problem, right, with fractions. You just keep the first one and change the sign to multiplication and then flip the second one. Now we just work it like a regular old multiplication problem. Well, we got a bunch of stuff that we can reduce here. Let me use a different color so that shows. I've got a 2, which can become a 1, and this 6 can become a 3. I've got an x here. Let me use this highlighter. This will work. I've got a single x here. Well, I've got two x's down here, so that one of these x's, the x on top, will cancel out one of those two x's on the bottom. So that would just become x to the first power, is what that would be. Okay, and then I've got a 9, which can become a 1 because it will go into 27, making it a 3. So let's look at everything I have here. This x should be canceled out. I've got, rewriting these fractions, 1 over 3y squared times 1 over, what's left down here is a 3x. Remember, one of those two x's got canceled out. Okay, so now I can just straight multiply, and my answer is just 1 over 9x y squared. I ran out of space there, but that's what it looks like. Okay, because once we reduced, there wasn't anything left on top. Everything that was on top of both fractions got canceled out. All right, let's look at another. 5x over x plus 2. All of that over, and I draw the middle bar bigger so that it's clear where it is, 10 over x minus 2. Again, just flip it. Make it, first write it as a division problem, so let's say 5x, I don't know how I just brought that window up. I'm always learning new things that I can do on here. On accident, unfortunately, so I don't know what I'm doing to do them on purpose. Panning hand. Why is that thing doing that? Boy, I wish I could figure this out. Instead, you just get to listen to me talk to myself. I have no idea. It keeps switching back and forth on tools. Anyway, divided by 10 over x minus 2. Fortunately, every time my hand touches the screen, it thinks I'm switching to a different mode, and I'm not. I'm just trying to write. Okay, well remember, for the sake of not running into this other problem, let me just come down with this. We're going to keep change flip, 5x over x plus 2, keep, change the sign to multiplication, flip the second fraction. Okay, now what can I do? Well, I can reduce this 5 and this 10. 5 goes into itself once, 5 goes into 10 twice. So now what do I have? Well, when I multiply, I've got x times x minus 2 over x plus 2 times 2. And you're thinking to yourself, surely we can do something else. Well, actually, no, we really can't do anything else. I could move this 2 in front of the x plus 2. Let me just do that, because people are used to seeing it there. People are used to seeing that number in front. Same thing. Doesn't matter where you write it. But that is actually our final answer. That's as simple as it gets. Believe it or not. Okay, let's look at another one. And this one is going to be done a little bit differently because of the nature of the problem. X over y squared plus 1 over y. And we're going to put all of that over. Let me go ahead and give myself more room. Again, I need to separate these. We're going to put that all over y over x squared plus 1 over x. Okay, there's a bunch of x's and y's. I know, it looks confusing. But this, we're actually going to want to work like what I introduced to you back in lesson 9. And look, I have it right up here so I can go back to it. Let me find what I'm looking for here. Well, these are all the examples I used, but remember basically what we did is we found the LCD of all the fractions and we multiplied by that LCD. Right? So on this first problem the LCD was 6, so I multiplied every single fraction by 6. Well, let me come back here and look at this. We can do the same thing within this complex fraction, and it's actually going to make our lives a lot easier. Well, let's think about what is the least common denominator. I have, let me list all my denominators down here in a different color. I've got a y squared, that's in the top left. I've got a y in the top right. I've got an x squared, and I have an x. Those are my two denominators on the bottom. So what's the least common denominator for all 4 of those terms? Well, it's going to have at least 2 y's in it, right? Because of this y squared, it's got to have a y squared in it. It can't go into y, it has to be at least y squared. And because of this x squared, it's got to have 2 x's. So then it makes sense that my least common denominator is x squared, y squared. Think about it for a second. You could make any 4 of these denominators become that. For instance, x, if I multiply x times x y squared, I get x squared y squared. So that denominator can become x squared y squared. And the same holds true for all of them, right? Okay, so here's what we're going to do. We're going to do what we did in the last lesson. We're going to take this x squared y squared and we're going to multiply every term by it. Let's see. I'm going to attempt to fit this in here. It helps that it's in a different color at least. Okay, now let's cancel out what we can cancel out. Let me go back to using the black tool. Wow, that's a giant equal sign. Oh well. Well, on this first fraction, I've got y squared over y squared. That cancels, so I'm left with x squared times x. Well, that's x to the third. In the second fraction, I've got a y, and that'll cancel out one of the y squareds. So I'm left with plus... Whoa, what is going on? It's panning on me again. I didn't ask for it to. Why is it doing this? I really don't know. Let's see if I can stick it on that. Plus x squared y. I'm going to have to play with this thing to get it to cooperate more. Over x squared and x squared cancel each other out. So what am I left with? Y squared times y. Well, that's just y cubed plus x, and one of these x squareds cancels out, so that's x y squared. Well, we got rid of all of those fractions. We now have just a single fraction. It may look kind of alike. It may look like, oh, maybe I'm done. Well, look at the top and the bottom. They're kind of in the same pattern. It's just that the exponents are switched. The x's and y's are essentially switching places on the top and the bottom. Let's look at what we can factor, because if we factor, we're going to find something kind of interesting going on here. On top, what can I factor? There, it went to that dadgum panning hand again. I didn't ask for it to, but it just wants to so badly. Well, on the top, I've got an x cubed in the first term. I've got an x squared in the second term. So that means I can factor x squared out. What does that leave me with? It leaves me with x plus y. Think about it. If you multiply out that x squared, you're going to get x cubed plus x squared y, which is what we have. On the bottom, what can I factor out? Well, I can factor out y squared. And that leaves me with y plus x. Well, let me get rid of this stuff and give myself a little bit more space here. Well, that, remember, because of commutative property, I can switch around this y plus x. I can rewrite it as x plus y. Well, my handwriting just got terrible for some reason. I apologize. Well, now I've got x plus y over x plus y. They cancel each other out. Remember, all I did is I took this y plus x and switched the order around and wrote it as x plus y, just to emphasize that they're the same. So ultimately, this is all equal to x squared over y squared. Ta-da! All right. There you have it. I do not remember if I assigned a negative exponent problem for this one, so if I didn't, you can look at the assignment, and if I didn't, then you can ignore this last example, but I'm going to go ahead and put it because I don't want to have to re-record a video because I chose not to do it the right way. Oh no, negative exponents, please, not again, no. Okay, the first trick here is rewrite it without the negative exponents. Remember, here's an important thing to remember. X to the negative 1 is equal to 1 over x. Or, w to the negative 3 is equal to 1 over w cubed. So to get rid of a negative exponent, all I have to do is flip that term down to the bottom of the fraction. So here's what we're going to do. X to the negative 1 becomes 1 over x plus 2xy to the negative 1 becomes 2x over y. We're just taking that y to the negative 1 and shipping it down to the bottom. Over 1 over x squared, x to the negative 2, minus 1 over x squared y. Okay, this looks similar to the last problem. Let me get rid of my little notes over here because I'm going to need this space. Well, they really don't want to disappear. Okay. This looks similar to the last problem. What's my least common denominator? Let's use blue. It's going to be x squared y. I've got an x squared here. I've got an x squared here. Just an x here, but that can become x squared by multiplying by another x. And then I only have a single y, right? I've got a y here, I've got a y here. I don't have any y squareds, so I don't need a y squared in my LCD. My LCD is just x squared y. So let's multiply everything by x squared y. X squared y, x squared y, and x squared y. Well, now what do I have? Let me come back to my black to deal with this. Well, I've got this x cancels out one of these x's. So now on that fraction I just have xy plus this y cancels out that y, and I have 2x to the third, because I have x times x squared, over this x squared cancels out that x squared, and that leaves me with y minus, well, what cancels out here? Everything. X squareds cancel out, y's cancel out, 1. Oh, interesting. What can I do with this, you say? Well, you can do a little factoring. It may not make, honestly, I would accept it at this point. But what can we do? We could pull out an x on top. And that leaves me with y plus 2x squared. All of this over y minus 1. It's not a pretty answer, but that is the answer. But I just wanted you to have seen one with negative exponents in it, and now you have. This completes all of Unit 1. At this point you should be able to do every single assignment. Remember, you'll have to get those done and make at least a 70 on each one of them before you'll be able to take the Unit 1 test, which you are responsible for scheduling at the testing center on your own. Okay, good luck, and as always, please email or call me if there's specific questions that you do not understand. Alright, good luck, and I will see you in Unit 2.